All right, welcome back from your break. This is Dr. Matthew J. Traum from Engineer Inc. This is the fourth video in the series describing how to use the PASCO finite element analysis software package to model the elongation of a metallic PASCO stress strain apparatus sample coupon under just 100 newtons of tensile load. So I have established the geometry. I've set up the mesh. There it is there. Talked a little bit about setting the boundary conditions, and now I'm actually going to go through the process of setting them. So in order to set the boundary conditions, I'm going to go to Analysis Settings. I'm going to right-click. There's an option to insert, and I knew this was going to happen. So that is out of the screen for your view. So what I'm going to do is just head over here and shrink this down and move it over, so you will be able to see what I see when I bring up that insert menu. So notice this is just a module screen, and the original ANSYS project workspace is still open behind it. So here, when I come over to Analysis Solutions again and right-click and hit Insert, you should, yes, now you should be able to see that. Okay, so there is a series of possible boundary conditions here. The one that I want is a force. Again, I'm imposing 100 newtons of force on this surface. So I'm going to click Force, and I'm going to come over here and make my way down to magnitude. So the first thing I want to do is change the magnitude of this force. Right now it's reading 0 newtons. I want 100, so I'm going to click on it. I'm going to type in 100. The units are implied, so I'm not going to type in any units, just leave the number 100. Hit enter. Now I've got 100 newtons, and then to lock it in, I'm just going to click that checkbox. Okay, so I've got my 100 newtons locked in. The next thing that I need to do is select the surface on which I want to impose my force. So under geometry, I'm going to select geometry. It's going to turn blue. I'm going to click no selection. This now is my opportunity to select the surface that I'm interested in. So I'm going to come over here. I'm going to click this guy. Aha, okay, great. And it should turn green, which is indicative that this surface has now been selected. So life should be pretty good, right? Well, I wander over here and I look at force and I notice there's still a question mark. So this has not been fully defined yet. What's the problem? The problem is that force is a vector, not a scalar. And even though I've imposed a magnitude and I've told it which surface it's going to act on, so it'll be acting normal to this surface, I have not yet told ANSYS which direction the force is acting in. It could start on this surface and be a tension force outwards, which is what I want, or it could start on this surface and be a compressive force inwards, which is not what I want, but I haven't told ANSYS not to do that. I need to tell ANSYS the direction of this force. So to get to the direction of the force, I head down here, see where it says direction, I click here, it says click to define. So I have two choices. Either the force can go outwards, like the arrow as it's currently configured, or I can go over here to this selection and turn it from a tension force into a compressive force. So tension, compression, tension, compression. Now I want a tension force because, again, the PASCO stress strain apparatus is putting this object under tension, not compression. So I want the arrow to point in that direction. And now that I've got it fully defined, I should be able to hit apply. Oop, what happened? I lost my geometry. So let me go back here, click on geometry, click this surface again, hit apply. There, now we've got all the pieces we need. So that was actually good. You guys saw that the selection of the force boundary conditions in ANSYS is a little bit finicky. You kind of have to do things in the right order, and it's not always clear what order is the right order, so you might have to revisit things a few times in order to get things to work out the way you want. But now I know that I've got my enforce my force imposed correctly. I've got a check mark here which says that the force is fully defined. This surface is red, which is ANSYS coloration code for surface which has a force imposed on it, and then this little arrow gives me the direction of the force, which is outwards. That's the tension force that I want. And if I move up here and pan this out of the way, well, this surface is selected. I've got my 100 newtons of force outwards in the x direction. So that is good. All set. So if I were to run the simulation now, unfortunately I wouldn't get the expected elongation. The reason for that is, remember that sum of the forces equals mass times acceleration, and in this case the sum of the forces is not 0 because I have not imposed some sort of counteractive force or restoring force on the other side of the sample coupon to counteract this force that I've just imposed. So if I were to run the simulation now, this simulated metal coupon would just sort of fling off to the right. It wouldn't elongate, it would just accelerate off to the right, which is not the desired outcome. So I do need to install some sort of restoring force on the opposite face. I'll show you how to do that now. So let me pan out. Let me use, whoops, meant to grab this. There we go. Let me use my rotating features to turn it over to get this face exposed. This is the face where the restoring force is going to be imposed right here. And right now I've got force selected, so I need to get out of that. So I'm going to go back to analysis settings. I'm going to right click. I'm going to hit insert, and here are all my different possible boundary conditions again. And instead of using a force this time, I'm going to select fixed support. Now, the reason for that is when I actually do the simulation, remember that one end of the sample coupon is clamped in and fixed in space, and the other one has a force imposed on it and it elongates. So the other face, the one that I impose the force on, is the one that's going to elongate, and this one is going to stay fixed in space. So if I click fixed support, this should allow me to click on geometry, move over here, and apply it to this face. Oop, okay, that did not work. As I said, locating forces, boundary conditions is sometimes a bit challenging, and I see the problem. I've still got my pan function here selected. So to get out of that, I'm going to go over here to where it says select mode. I'm going to click on this and single select, and now I should be able to go to geometry, yes, and click on that face, hit apply. Excellent. Okay, the face is turned blue, which is the ANSYS color code to tell me that that support is fixed. If I go over here and look at the fixed support that I just created, there's a check mark, which suggests that it is fully defined. So I've got my force, I've got my fixed support, and I am now ready to go. So I'm going to just click out of this into solutions. I'm going to pan and zoom my way back to the original view, more or less. There we go. Okay, and now I am completely set up for running the simulation. But I'm about at 9 minutes, and once I do the simulation, there's a lot I want to talk about. So we will wrap up this video here. You guys can take a little break, but please come back and join me for the final video, which will be an actual running of the simulation and then a evaluation of the results. Okay, see you in a little bit. Thanks. Bye.